the OCP Summit coming up, we expressed some interest in doing something for the telco group or for the telco and edge groups, even though we don't have an official track. Do you know, Craig, if any inquiries have been made about us getting be able to have a lunch or a room or something on site there at the convention center?
Yeah, I've not heard anything back, but I'll make the assumption that they'll be more than happy to give us like a table or something. So the thing would be when the day that it'll be and where. I don't think it'll be an issue though.
Okay, I think we should work towards that. I also was thinking earlier that we should, once we get that set up, we should reach out specifically to some of the big telco customers that have representatives at OCP, and try and get some specific people from like AT&T, Deutsche Telekom, other carriers to specifically join us for that meeting. I think that would be a good way to reconnect and stimulate some discussion about where they're heading. One of the things we've noted is that we're not getting any new specifications coming from the telcos for specific, products or equipment or such. A lot of the work in the telco group has actually been happening over at TIP, in particular with Open RAN, be good to use this event with on-site participation by members of OCP and focus specifically on pulling in some of those carriers into our discussion for that. So, Craig, why don't you and I work on this, and John, over the next couple of weeks and see if we can't get commitments and line up and see if we can get a table or a room or something over lunchtime and have that kind of as a informal group meeting place, and then we'll try and pull in some of the specific people if we can once we get that in place.
Okay, yeah, I'm not sure I'm going to be able to make it. Craig, I don't know what your plans are.
Yeah. So Bijan, you joined, I see.
Hey guys, yeah, I usually have a conflict, but that conflict got canceled today, so here I am.
Yeah, so we're talking through kind of what the telco and edge groups can do at OCP Summit, even though we don't have a specific track. And so we're hoping to put together like a lunchtime informal gathering, either at a table or maybe even a room. Yeah, on one of the days.
Sure, we can probably get you a room.
That would be great, and we can advertise it. And then I was saying specifically, once we get that in place, then I will work, with you or others to pull in specific telco customers to come back and participate in that discussion. Make sure they're invited specifically for that. I think that'd be a good way to try and pull that together. We've kind of noted that we're not getting a lot of requirements coming from the telcos in terms of specific products like we used to. So a lot of the early activity in OCP was driven by AT&T, Deutsche Telekom, others coming with some specific product proposals to meet different needs in their network and stuff. And they've kind of backed off on that over the last couple of years in particular.
So I think
this would be.
Yeah,
go ahead.
One area that you guys might want to consider is that there's this whole edge MHS thing that's been started. And I would recommend trying to round up everybody in the telco community that you could to kind of help provide input into what would make that the right product for telco. I think the opportunity is just to take whatever, development that comes out of that and then kind of you guys refine it, right? So let's say they publish eventually they publish some base specs for edge MHS, then you guys turn around and take inputs from the community and then use those to refine those and say telco edge, that was just kind of something I thought was low hanging fruit and probably useful to
Yeah,
everybody.
and in fact, we had a presentation by the MHS guys last month or the month before in the telco meeting, kind of bringing us up to speed on what the whole kind of structure of the MHS program was. So
Good.
we made the first connection with that, and I think in some sense, the telco and edge, it's really about taking some of that and moving it into harsher environments, right?
Yep. Yeah, I
Yeah.
mean, when I was talking to somebody today, in fact, they were asking about some things, and I was kind of setting I was kind of saying that we have an opportunity here. There's like a near edge and a far edge, and in the near edge, all these edge MHS boxes type things are fine, right? Because they're in nice data center type of environments. But the far edge, you don't know what the environment's going to be. Could be nice, it could be harsh. And so for those, you have kind of the telco requirements, right? And so internally, there's a lot of support for this approach. It's just that the community's got to do it.
Cool. Yep. So we'll work on maintaining that connection and following kind of the approach that they're taking in the MHS group. And they've considered edge a bit, but I agree. Sometimes their edge means data center edge or colo location for cloud edge. It may or may not get to the central office or the far edge being maybe outdoor cabinet equipment or uncontrolled temperature environments and wherever.
In fact, when you think about the Open RAN specs, depending on what your split is that you're trying to serve in your use case, that would kind of drive like where that would be, right? And so you could even get it to the site level, right? Where you have these things co-located with the radio units. And so you absolutely need like the maximally survivable, version of this thing. And they don't care about, the guys who are developing it in the data centers are not really concerned with, all the ins and outs that have to be considered.
Yep. And I think, quite frankly, we have, the edge chassis, right? Which has, it's modular in terms of kind of the blade structure of it and kind of followed some already standard modularity in terms of mezzanine cards and PCI Express cards, et cetera, et cetera. That's not quite the same paradigm as what the MHS guys have been doing, where they've been doing basically internal product modularization, right, or commonality or form factors and such.
Yeah, and I think the big thing there is being able to swap out the CPUs. And that kind of thing.
Yeah, so I think that's one of the evaluations we have to kind of look at and taking what they've done in kind of a, standard 19-inch or open rack form factors, modularity inside those products versus, kind of a bladed chassis that we already have that has some standard, more standards-based modularity that was existing in the industry for years now, right? And a lot of that stuff, a lot of the stuff there was like, 2-socket, high performance CPUs and such. And our edge chassis is more like a, single CPU socket kind of stuff.
Yeah, I haven't really been I haven't been here. I haven't been there either. I have a conflict there too. So I don't know where they're at right now, but
okay.
The vision was that they were going, so the edge, so the DCMHS is like this you know, family of standard sizes and, you know, with power,
Yeah.
IO, you know, all the pieces of it, it's all modular. And so, theoretically, you know, anybody could come and build, you know, in the open edges paradigm, it'd be like a sled, right? But in that paradigm, it's not quite, you know, field replaceable. So it's like, you
Right.
know, it's modular, but it's not field replaceable. So there's a slight difference there. But
Yeah.
but other than that, it's the same concepts, right? Like where you have standardized, you know, half width and full widths and, you know, 1 RU, 2 RU, you know, those types of things. And so that part of it's the same. And from what I was told, from the edge guys, there was probably opportunities to even go down a level and even create more universality between the edge chassis that we have today and what they're doing. And the benefit, of course, would be, you know, commonality, right? So you still get the economies of scale where these guys like, well, these ODMs can make, you know, millions of the same thing and it could be used in different ways. So,
Yeah.
so the goals are kind of, you know, they're not far off. The products are not that far off, but there's, you know, there are differences.
Yeah.
Yeah, and then one thing too is this whole AI thing just keeps getting hotter and hotter, and especially in the distributed fashion, right? And that's so interesting about that is that's sort of counter to where everybody was going with this edge stuff, trying to make it more power efficient, you know, less heat generated, all that kind of thing. Now this AI trend flips all that on its head.
Yeah.
Yeah. It's they want it on the edge, but it's more power and more harder to cool, et cetera, right?
Yeah.
So I made a mistake, you know, like a year ago. I went into a board meeting, OCP board meeting, and I said, they were like, okay, what's the future? I said, well, the future is all of this AI stuff's going to go out to the edge. And so you need to be able to, you know, we need to design for that now. And the board is dominated by hyperscalers. So they kind of like rejected that notion, right? That no, it's all going to get bigger, centralized. But I stand by it. I'm pretty certain that AI is going to be leveraged everywhere for automation and, you know, other things. And I think that it's going to be mostly okay. So it'll be inference at the edge, right? But it'll be mostly at the edge. And no, so we all have
You
to
know,
get our minds around like what do we need to enable that. Now it doesn't need to be the same. It's not training, right? We're not going to go to a cell site and train a model, probably, but
a
you know, we
couple so Bijan, a couple things here. So one of the
Yeah.
big things that's pushing this to the edge is data sovereignty and you know concerns that your data escapes.
true.
So the closer you keep it local, the better. And then the other issue that's also, you know, so that kind of flips the hyperscaler thing on its head. Then the other thing is there's this whole concept of RAG, which lets you tune your model. And so if you think about this locality, you may want to have local tuning in rags that you don't want to make a big giant rag in a hyperscaler. You'd want to kind of keep the rag local to whatever those local issues are that you want to kind of tune your model to. So that is kind of there is some aspect of training, and that's this building of the rag.
You're absolutely right. Yeah, no, you're absolutely 100% spot on. Like for sure, there's going to be fine tuning, you know, for, you know, individuals. Like if you have two operators that have, you know, AI at the edge or whatever, and they even if they introduce the same services, they have different service profiles, or they have different customer bases, or they have, you know, and so
Exactly.
you're 100% right. I agree with you.
Yeah. So I think these initiatives also I think kind of drive us to look at this modularity and openness into this hardware space.
Yeah. So maybe you can if you have an opinion. So kind of my opinion is that there's going to be a whole bunch of models created, right? And you know, some of those will be publicly available through clouds like Google and others. But there'll be other models that are like the whole model's publicly available, and the real trick is taking models and figure out how to make money on them with inference, right?
Yep. Yeah, I think that's the big thing that still needs to be figured out is how people plan to monetize this.
Monetize it, yeah. And so I think you were sitting there going, it's hard to monetize it. It's hard to maybe I don't know. Maybe it seems hard to monetize creating a model, right? Because it takes tons of data and tons of compute and stuff to actually create the model. And then, you know, once the model's created.
But Lauren, don't forget the telcos, they own a lot of the data, right? So they have access to a lot of data. And so they're able to train, they would be able to train AI models for a lot of different, but the way I think it's, you know, I don't want to confuse AI. The way I see AI being used is more along the lines of automation more than just the LLM thing that we all focus on today, you know.
So that's a really interesting question about, you know, how do you monetize that, right? So you can sit there and say, well, you know, a telco could use AI to increase their operational efficiency, right? And that is it's a way of maybe reducing cost. It's not really, you know, direct monetization of technology, right?
I've been down that road, and I have many. I got a flat head to prove it, right? So carriers don't buy savings; they buy revenue. So
right.
Even if
it's our business case to make.
Yeah.
Yeah.
Interesting.
Yeah, I mean, if you look at, I mean, I could throw a million examples, but the most famous example is small cells. Like, what would be the best thing for a mobile network? Small cells everywhere. What's the last thing you'll find in a mobile network? Small cells everywhere, you know? So, I mean, there was just no pathway in their business cases to monetize or to build the revenue side of that equation. So nobody touched it. Nobody, it's looked at like the plague, like a tax.
Yeah, that's why I have bad coverage at my home.
Yeah. I mean,
I'm
it's
too
true
far
with all
away
of us,
from
right?
Yeah. No, and that's pretty obvious. Like, I mean, there's a huge difference for me in terms of, I get on a major highway and I've got good coverage. I get off, you know, to my home and it goes away pretty quickly. Because I'm out in, I'm out in the country a little bit.
Well, I mean, so I spent my time in small cells, and I could tell you that the coverage side of it was one thing, but they would literally, the big guys like AT&T and Verizon and T-Mobile would save billions of dollars in capacity costs with small cells. Because maybe they already have macro coverage, but they could siphon off, you know, capacity of people sitting at a traffic light or capacity of people indoors or whatever it is, right? And so, but they just never were willing to make that leap because, you know, it just didn't add to the bottom line. And I think that's true here, you know, for Edge is like when you frame it in terms of, well, yeah, we could put AI at the edge and we can save you lots of money. They're going to yawn, right? They're going to be like, I'm not really interested.
We know this, the recent issue of the IEEE Explorer has a pretty good article on the 3GPP 6G core that, you know, they're wanting to start calling it AI native.
Oh yeah.
Right. So instead of it being, you know, bolted on after the fact, the 6G is supposed to include AI, you know, in the design. So for all of the designs this time for 6G will include, you know, an AI component. So it'll be something that, as obviously we focus a little bit on 5G, but as 6G starts coming in, the AI will become, part and parcel of that new 6G network.
That's
It's a
true.
pretty good
6G
read.
network, as in using AI to do inference to better control the network or better control the.
Yeah, not only control the network, but right now, your the most computationally intense parts of the network is the channel coding,
Yep.
the LDPC codes, the polar codes that are used for control plane and the user plane. And so they're talking about using AI models to then be for that purpose to help speed that up.
Okay.
That'll give you significant benefits, at the carrier level to increase the throughput, the spectral efficiency, beamforming, massive MIMO calculations, all those kinds of things will be done. So yeah, I mean heavy inference, but it'll require some new AI models. But again, it's still 3GPP has just started looking at 6G and the protocols that are come out. But one of the founding, ideas is that you're going to be AI native. So you're not going to bolt AI onto the back end to do management, that kind of thing, but it's going to be incorporated into all of the protocols.
So that would imply that they'll create the models, and even out on the edge or out near the radio units, they'll need some quote acceleration, right?
Yeah. So to Craig's point, many years ago.
It's still evolving. I'm not sure. It's kind of the same way with the 5G channel coding, the LDPC that was pushed into use from what we were using with LTE or the 4G. We're going to see a similar exploration of AI topics and how it can be incorporated into the protocols themselves this time. And like I said, it's still evolving. I don't think we've got all the answers. There's a lot of work being done. And, when IEEE Explorer starts talking about 6G topics, it's usually a good read and it's a good way to follow kind of what's going to be on the horizon. This is certainly not, well, we just got the last release of 5G, so you got another 4 or 5 years probably before 6G's out.
Well,
Yeah.
and
We'll
even
have
then,
heavy AI components, all I'm saying.
Yeah, and even then, it's like, okay, so you need computation, you need some, model acceleration. What form does that take? And obviously, as you get out to the edge, you get into this cost-sensitive space where the answer is probably, AMD and Intel building into their CPU ASICs the acceleration needed for those kinds of workloads, so you don't have to have, 700-watt piece of silicon in addition to your, standard CPU out there running this stuff, right? So
yeah, take a look at this next generation of Windows Copilot PCs. They've got this neural processor stuff already built into the to the CPU, right?
Yeah.
Apple's had that.
Not only that, the UE, the handsets are going to have
right.
The reciprocal end of that. It's not like you can have all the computation at the radio tower. It has to be then, encoded and decoded on the individual handsets themselves. You may need, bulk processing at the antenna sites, but you're still talking about, the ultimate edge, right? Which is the thing you carry in your hand or in your pocket.
Yeah, used to tell the story when I was at the startup of, they would ask what's the future, and so for wireless, at that time what it looked like was, so there was a lot of interest in like ultra reliable low latency communications, URLLC, and IEEE has a version of that for Wi-Fi, right? So that there's they have the same idea, And you know, and all these use cases were like robots and medical surgeries and all these different things. Well, anyway, you know, I think a couple things have changed on that too. I think self-driving cars makes that kind of more interesting. But anyway, I don't want to go down that rabbit hole. But the point is, what you needed was a cognitive radio. So you would have this radio could be of any protocol, and you needed something fast enough to recognize what protocol it was speaking, and then to respond to it in that protocol. And really, that all pointed towards AI. That all was like, that's an AI capability. So at that time, that was where we thought, you know, we thought it was definitely going to be, and you're right, it had to have control over channel coding, you know, the protocols, including the physical layer and the transport layer or whatever. So it was a lot of complexity, but you didn't have to have hard coded ASICs, you know, at that point. You could have it all in software. So that was years ago, and it doesn't look like it's less true today. It looks like it's still kind of headed that way.
Yeah, so there's this fundamental, you know, difference, right? I keep asking the question, what's the difference between a good algorithm and you know, an AI? And it's this idea of, you know, creation of a model of some sort and encoding that modeling, and then, you know, I assume that most of those models ended up being neural network models, right? That you kind of ping and process or inquire against. But so this is like a fundamental divide, right, between a good algorithm and the need for AI or a model, in terms of when do you get better results with a model and AI techniques versus just, you know, either a hardware or software good algorithm that's required for this stuff.
Yeah, I would so I would offer that your algorithm is deterministic,
Right.
where the AI approach, it can do some weird stuff, and it's not necessarily always doesn't always give you the same answers again. Right?
Well,
you can ask the same question,
right.
Well,
so this is one of those things where you sit there and go, yeah, I want AI to drive my car, right? But you really don't want that AI driving your car to hallucinate.
But I mean, but conversely, if you had an algorithm driving it, like that stop sign better be visible all the time, or something bad's going to happen, or no one better jump in your lane, or, you know, there better not be a different kind of truck that gets invented that gets on the road.
Yeah.
Whereas the AI adds a fuzz factor to everything, which could be good and it could be bad. Yeah.
Yeah.
But I mean, I think we're in the early innings. Just like, you know, in the beginning of wireless, we made a lot of stupid mistakes. Same thing with AI.
Yeah.
We're just basically infants with this thing, running around trying to see all the different things that we could do with it. And I think at the, you know, end of the day, it will get to be fairly sophisticated, but I still believe it'll be very invisible. I think it'll be like embedded everywhere. You won't really be saying, hey, that's AI. You'll just be saying, that's a competent device. You know?
Yeah, no, I agree. And, you know, and I think, you know, part of the prognostication, you know, sitting here is the telco and edges, you know, what form does that acceleration or that model processing take as you move from, you know, the current huge GPU clusters, you know, in clouds that are being created? How does the actual implementation of that change over time, over the next few years, as you move out towards the edge? And, you know, is it based on the same GPU technology, or is it based on something different? I know I've heard that, you know, Intel has some chips that they put together that are not standard GPUs. They actually, I think a lot of the models are based on neural networks, but right now, if you use it as a GPU, you're running that neural network on a digital platform, right? Whereas there's a bunch of other ways to use silicon to build neural networks where they're analog, or they're not untimed or whatever. and they actually can run things faster with lower power, right? So there's a whole set of other technologies that people are trying to come up with that aren't based on, quote, standard GPU models coming out of AMD or NVIDIA in particular, right? So NVIDIA landed on this because they had GPUs that could do parallel operations, but they're still clocked, they're still timed clocked calculations in a floating point parallel processor, but they're emulating neural networks. They don't really implement neural networks, quote, directly, right?
Well, that's just the case of,
Hey, Lauren, I put a YouTube video about it's a really good
explainer.
article about watching neural networks learn functions. So, basically all of these wavelengths and the different things that we're doing is a function, right? And so
Yeah.
what you're not trying to implement the function in an algorithm, but rather have an algorithm that can figure out what the function is and to fit the function. So it's kind of an interesting, it goes a long way towards what you're talking about, the difference between, implementing an algorithm and having something that can learn what that function fitting, to approximate that function without having to know what the function is.
Yeah, it's kind of like the Fourier transform things, right? You're trying to do curve fitting, and rather than actually knowing the actual formula for the curve, you're trying to reverse engineer it, sort of.
Yeah, well, I know this. So this chip from Intel, I think it's a second generation chip. I can't remember the name of it, but
Gaudi
has interesting. Yeah, no, it's not Gaudi. It's actually a more experimental version than that. And I can't remember the name of it, but they offered for like a research tool at this point, second generation.
Are you talking
but
about
it has the interesting.
The neuromorphic processor?
Yeah, exactly. And it has the interesting property that you don't have to separate it into, quote, machine learning and then inference. It actually does them both at the same time.
Yeah, I think that again, when you look at the history of wireless, for example, Qualcomm made these massive chipsets for CDMA. They were pretty massive when you look at the overall size and scope of what was on that board at that time and what they were doing. And over time, technology's gotten more, capable or whatever. So I think GPUs kind of follow the same evolutionary path, like the AI on GPUs. I mean, AI. So AI starts with GPUs because it's easy, right? And you can run.
You can do it.
A lot of math.
Do it mostly in software, right?
Yeah, it's all math, right? All these
all math.
It's all math. And then the next iteration of that's like, how do I optimize it or tweak it? Well, now you're going to put a lot of that, you're going to hard code it in hardware. And so, guys that have like NPUs and other things that we haven't even seen yet that are coming out, they're going to change the game. And so NVIDIA's got to keep, innovating, or they're going to get left behind for sure. But I think how that influences the edge stuff is that we have to be very, adaptable, flexible, scalable, so that, we're not prescriptive. We're not saying, hey, it's got to be, it's got to fit two, B200 GPUs. It needs to be something like, whatever you could fit in this space with this much power budget and this much IO budget, right? kind of thing, kind of approach.
Yeah, that's what makes this MHS thing interesting, because if you look at some of these ARM processors that are coming out, like folks from Ampere, they're putting like 250 cores, and so that's kind of what you guys are talking about. The GPUs took off because you have a lot of these math cores, but if you look at kind of just what's kind of happening, regular CPUs are starting to get a lot of cores too, and you can do that parallel processing.
Yeah, standard cores. Well.
Yeah.
Nope, understood.
And I think another trend here is that RISC-V, is open, and so there's going to be a lot of tinkerers and, entrepreneurs and engineers that come and find better ways, and they're going to be able to implement this kind of open hardware. So you're going to see like this explosion of ideas at some point. Not GPUs, right? They're going to be different. They're going to be more CPU or more, I guess you'd call it XPU type of architecture.
Interesting. Okay. So, some of the implications for that really are back to the, foundational concepts of how much space, how much power, and in particular for those, harsher environments, how prepared do you need to be to supply something other than just air cooling, right?
Yeah.
And so, some of the cold plate liquid cooling, probably some of the cold plate, closed loop cooling, right? So it's not like a lot of these environments are going to have, data center, open rack, additional cooling, external cooling stuff. But bringing to bear the set of technologies that allow, more power at the edge to accommodate, whatever level of integration is coming down from the ASIC vendors for supporting AI. That's probably an interesting place to talk about both the environmental stuff plus the modularity, right? It kind of would come together at that point.
Agreed.
All right. Well, any other comments? I think, that's a good conversation. I'm glad that you have recorded this meeting, and this certainly sets up some topics to engage at the OCP Summit with whatever forum we've got there.
So I put a note out to Michael, Shell, and Rob, and I said, hey, let's see if we could find some space. So we can do that for you.
Okay. And I think at the last OCP we ended up having like a Dent meeting, if I'm not mistaken, or maybe that was a different conference.
Yeah, no, yeah, they had Sonic and Dent.
Yeah. There's some there's a room downstairs, I think, that was like a little off center, but actually pretty nice. At one end of the San Jose Convention Center. I forget exactly what it was. All I remember is that we went downstairs and there was a nice room there. And
yeah, I think I had a meeting with Nokia there one year.
Yeah. Anyway, okay.
It was the room with windows, the conference room with windows, right?
Yes. Yeah, it was very nice. I liked it. Anyway, that was just a side note. I don't know if it's available or if it's open for the conference to use and stuff. I assume it is.
Yeah, I don't know. I've asked. I'll have them kind of give you guys the options.
Okay, thanks. Any other questions or comments before we break? All right, thank you all.
All right, thanks everyone.
Thank you. Bye.
Have a good day. Bye-bye.
Bye.